Good afternoon, ladies and gentlemen. My name is Okokubonsu Agnes, and I'll be taking you through the fourth generation computers, microchips, microprocessor architecture. So, lesson 1, we will talk about the history of computers span several decades and is categorized into 5 distinct generations. Each generation is marked by significant technological advancements that fundamentally change how computers operate, leading to more compact, effective, and powerful devices. This discussion focuses on the fourth generation, which followed the third and was characterized by the development and use of the microprocessor from approximately 1972 to 2010. Continuation of the lesson 1. The development of the microprocessor by Intel in 1971 revolutionized computing, enabling all components to fit on the single chip. This led to smaller, more powerful computers and eventually the development of personal computers like IBM and Macintosh. Microprocessors also began to appear in everyday products, and the increased power of these computers enabled networking, which ultimately gave rise to the internet. So this is a picture of the microprocessor. My colleague will take you through lesson 2.
Lesson 2. I'm going to take you through Lesson 2, the Intel 004 microprocessor. Examples of the fourth generation computer includes desktop computer, laptop, workstation, introduced microchip integrated circuits. Microchip made from silicon store data in binaries and require power to function, used in computer, phones, cars, microwaves, washing machine, TV, and many more. And these are some of the examples of fourth generation computer.
Okay, so in lesson 3, we have the types of microchip. The DRAM, that is dynamic random access memory. It is used in desktop, laptop, workstation, and gaming platform. So we have the NAND flash. It is used in main memory, in memory card, SSD, and USB drive. Then we have the NOR flash. It is reliable storage for storage for boot, OS application, and has some data storage. For microprocessor, it is used for computation, communication, multimedia, automobile, and industrial processes. And we have the top manufacturer. That we have the Samsung, Intel, Qualcomm, SK Hynix. So these are the examples of the DRAM and the NAND flash and the NOR flash. Okay, we are continuing with processor architecture. A processor architecture is also known as microprocessor. It's a key component of a computer system. Architecture in computing refers to the design of computer system. Also, processor architecture defines how the processor is built and functions. It determines which software and hardware components are supported. Examples, here are the examples. The Intel x86 processor architecture is widely used. Okay, I'm continuing with lesson 4, a single core CPU chip. The image illustrates the architecture of a simple core CPU chip. A common design is most personal computers. This design allows computer manufacturers to create machines with different hardware components that can still run the same time. Okay, my fellow colleague will continue.
So we are in the last session of this lesson. This lesson talks about the chip. It talks about the CPU chips includes. So the first one is the register file. that is store data instruction for quick access. 2. ALU, that's the arithmetic logic unit. So this unit, it performs arithmetic and logical operation. The next one is the bus interface. So the bus interface connects the CPU to the system bus, facilitating data transfer between the CPU and other hardware components. 4. The system bus, a communication pathway that links the CPU to other parts of the computer. So this standard architecture ensures compatibility and flexibility in computer systems. Now, let's talk about the internal clock. These devices is derived from the system clock of the computer, ensures synchronization of the computer processor, controlled by a part. Again, it is controlled by a part oscillator that supplies timing signal at a fixed rate. Again, it regulates execution of instructions and coordinates computer components. Now let's talk about the internal buses. So the internal buses is a cables that connect various components of the processor. It facilitates data transfer within a computer system. Now the last one, that's the logic gates. So the logic gate controls the flow of information in the processor and the entire computer system. Okay, so I'll end it here.